Arun Gupta. I am a vice president and general manager at Intel. I lead the open ecosystem team here. You can learn more about us at open.intel.com or find us at a beautiful podcast that my team hosts on open.intel.com as well. And today I'm super excited. This topic is very close to my heart, and I'm very happy that I have Fan here on the show. Hi, Fan.
Hi, Aaron. Hi, everyone.
Wonderful. So the I won't do a justice to the topic, but really we're talking about how do we do what work we have done in the upstream community in PyTorch 2.x and how that work is available to you in the latest release AWS m7i and c7i instances. Fan, welcome to the show. Tell us what you do at Intel.
Okay. Yeah, so I'm supporting the PyTorch engineering team at Intel. So my team has been sort of like doing all kinds of optimizations and development around PyTorch. Um, yeah, so that's actually a very great project with very energetic community, and yeah, it's super. We are super excited about all the progress that we have made there, and everything that we are doing or going to do. Um, yeah, so I guess I can briefly talk about the
Well, so
optimization.
you said that your team is contributed to upstream PyTorch, right?
Yes, we are contributing to upstream PyTorch, and actually we are sort of leading a lot of CPU related development and optimizations in Start PyTorch. Even though like we also maintained a sort of an extension called Intel extension for PyTorch to stage some of the optimizations there. But in general, like our strategy is upstream first, and we upstream things in Start PyTorch as much as possible. And when there are cases like it takes some time to get some more complicated or aggressive optimizations to land in PyTorch timely, we deliver those through our extension so that users will still be able to experience the greatest performance uh, like as early as possible.
And those extensions are really just a staging ground, in the
Yes,
interim until they are accepted upstream, because the philosophy is upstream.
exactly.
Beautiful. Yeah. I mean, I think this is, and a little known fact probably is Intel is one of the top three contributors to PyTorch. Is that right?
Yes, we are. That's correct. Like we are kind of like one of the top corporate contributors in PyTorch code base. We are sending a lot of commits uh, and PRs in the PyTorch code
And
base.
a testament to that is, like, when Intel put a request to join the PyTorch Foundation as a governing board member, it was unanimously approved, and now we are on the PyTorch Foundation governing board.
Yes, we are super excited about that, and we would like to work with the other partners to accelerate the development and also the democratization of PyTorch.
Beautiful. All right, let's take a look. What you got here. I know you have some slides.
Yeah,
So we're gonna bring up the slides. Okay. Let's do this way. So, all right, Fan, walk us through what content you have.
sure. I don't have much, but yeah, I guess I can briefly walk through all these things there. As we just talked, like our strategies upstream first. Actually, we have a long history working in PyTorch community. Um, like as we all know, like Intel is continuously infusing AI features in our Xeon processors, like AVX 512 in the early days, and then BNI and BF16, and in the latest fourth generation Xeon processor, we have AMX there, right, which is a built-in accelerator for matrix multiplication. Like we part of the work that we do is to ensure like all this AI hardware features are able to be exposed or utilized by PyTorch so that users will be able to get accelerated performance with these features for their workloads. So that's a big portion of the work that we do. And the other part is there are also um, software features that are evolving, right, for either performance or productivity, right? And we contribute or like contribute to the development of those features. Um, some of them may not be specific to a generation of hardware, but they're in general good for performance or productivity. And we do those as well. Examples like the auto mixed precision or like the quantization backend, those kind of stuff. And that in the latest PyTorch 2 series, like PyTorch 2.0 or 2.1, like there are a lot of work in the compiler space, and I'm going to touch about that a little bit because that's really good stuff that I believe like would be beneficial to all of the PyTorch users.
That's wonderful. This really goes back to the philosophy that Intel talks about, software defined, hardware enabled. So we build up these accelerators, these features in our chip. So you contribute upstream so that those features can then be utilized. So end of the day, our customers who are trying to leverage or run PyTorch 2 in any cloud of their choice or any data center or on a laptop, these features are just working with them in the most optimal manner out of the box.
Exactly. That's what it's about. Like all the work that we do is for that target.
Wonderful. Let's see what we got.
Okay. Yeah, and as I just mentioned, like we have the Intel extension for PyTorch, and sometimes people like to call it IPEX, right, to stage some of the additional performance optimizations um, for the time to market value. And in the latest PyTorch 2 releases, since there are like kind of like many hardware vendors do the Torch Dynamo backends, and IPEX is also shown as an open source but out of tree Torch Dynamo backend that people can use and very easily play with it to get the additional performance boosts. So all we want to do here is to kind of like get it a drop-in experience so that people don't really need to change a lot of user code in order to get this. Actually, it's just kind of 1 or 2 lines of code changes in users' code base in order to get the benefit here.
So even though these are Intel extensions, but they're 100% done in the upstream work. So they're still open source.
Yes, it's completely developed in an open source fashion. Um, and yeah, so people will be able to either get the release, like we usually do the release, like very close to the PyTorch release. Like for example, PyTorch 2.1 is released like within the next one or at least 2 weeks. Like we will be able to get the IPEX release working for the corresponding PyTorch release, and people can also kind of follow our master, right, in order to get the latest great stuff from there. Yeah, so it's totally open source development model, and we monitor all this GitHub ticket stuff, and people can report GitHub tickets to us, and we will be responding those timely. And people even can contribute code if they want.
Right. So PyTorch goes live, in a week or two. You have the extensions available as well, which are again
Yes.
done in an open source. So pick your choice and then run with it, basically.
Yeah, exactly.
Beautiful. All right. What else?
Let's see here. Oh yeah, I just want to mention, like, even though like I talked a lot of things about the work in the PyTorch core project, right? But then I guess the open ecosystem of PyTorch is actually one of the most powerful advantages of PyTorch, right? So we also extend our work beyond the PyTorch core, and we do a lot of work in its ecosystem libraries as well. There are many, right? So I'm not able to kind of get everyone listed here, but here are some of the examples that my team contributes to ensure that the users of this ecosystem libraries or the open models, right, are able to really get good performance and experience as well. Yeah,
So
so
not just PyTorch itself, but the libraries and the models that leverage those extensions, they are aware of these upstream contributions. So different layers of the stack where customers are seeing benefit of these optimizations.
yes, exactly. And actually, a lot of people are using PyTorch even are not aware that they're using PyTorch, right? Their access point could be like some of these ecosystem libraries that is built on top of PyTorch, right? So we want to ensure like at least the key pieces of them, like we directly contributed to those libraries in their corresponding upstream projects as well, so that people can get like very out-of-box experience and performance based on what we have done there.
That's wonderful. All right.
Okay. Yeah, so this is kind of like, as I mentioned, like in the fourth generation Intel Xeon processor, one of the hero AI feature is AMX, which is advanced matrix extensions, right? And it's kind of like a built-in accelerator in CPU core to accelerate the matrix multiplication, which is kind of like a key piece of the deep learning workload. And it supports Intel and BF16, which is kind of like the commonly used data type in the deep learning framework, deep learning workload.
So talk a little bit more about the AMX. Go back for a second. So yeah, now when customers are using Sapphire Rapids or fourth gen Xeon or the
Yeah,
seventh in AWS, which is M7i C7i,
yeah,
they can download upstream PyTorch, and in that fourth gen Xeon, this AMX accelerator, which is as part of the chip itself, but instead of running on the main CPU, you offload it to the accelerator, and that's where this int 8 and BF16 are supported, and you can
yes,
do faster matrix multiplication. That is a typical workload that you
yeah,
need for AI.
yeah, yeah. And actually, all of these things, like users do not need to really do anything special, like because the AMX is kind of enabled and turned on by default in the PyTorch code base. So people just download the stock PyTorch, the binaries, right? And then they just run their workloads. They don't need to do anything that is specific for AMX.
I think that's the beauty of it. Like it's 100% upstream compliant. Just use straight up PyTorch, from upstream, run it on a stock M7i C7i instance on AWS, and you get all the benefits out of the box.
Yes, that's
Beautiful.
right. Yeah, I do want to talk a little bit more about the new features in PyTorch 2.0 or 2.1. Like I guess people who are familiar with PyTorch, like when people hear about PyTorch 2, I guess the keyword that would pop up in people's mind would be compiler, right? Because the PyTorch 2 is essentially a compiler story. And then like it has like this torch dynamo and inductor as the critical component for the compiler implementation. And then Intel is sort of like lead a lot of like the development and the optimization for the torch.compile, torch inductor CPU backend. Right, as we all know, like there's also an inductor. So like the in-tree backend has a GPU backend and a CPU backend, right? And then we are sort of like basically leading the work in the CPU part. And then like in PyTorch 2.0, like we have the initial support there and get all these parts working and get IP32 data type optimized. And in the 2.1, which was just released a couple of weeks ago, like we get BF16 fully optimized as well. And we also get some sort of prototype optimizations or implementations for Int8 there. But then like the whole Int8 thing is still evolving in the PyTorch in general, including the quantization flow and everything. And all this stuff is positioned as a prototype feature there. But I guess we will be continue to work with the community to mature it and make it a stable feature in the next releases. And then we also add some sort of additional software features and support there, like the dynamic shape, right, and also like the CPP-based wrappers to reduce the overhead and all these kind of things. And by the way, like since the large language models and like the NLP workloads are sort of really like driving a lot of demand right this year. So like the scaled dot product attention or flash attention is a critical piece there for the performance. So we also get the flash attention optimized for CPU install PyTorch. And we also optimized for some GNN workloads like the graph neural network workloads, which is also something that a lot of people are interested in for CPU in PyTorch 2 as well.
So even though customers may be spending a lot of time in training their model, but a far more time is actually spent in inferencing those models. And that's
Yes.
where all of these optimizations are super relevant. And in some cases, it might be okay to leverage CPU for the training part of it as well.
Yeah, exactly. I guess like we believe that like inference, as you mentioned, as still like majority of the cycles, right, would be spent on inference and CPUs or like the fourth generation Xeon, right, as with the AMX support is actually capable of doing a lot of inference work, right? In many cases, even for large language models, right, in the inference scenario. And then like for training, like for smaller models, like as we have been demonstrating through multiple rounds of MRPerf submissions that Xeon is capable of doing training for small, medium size of models. And also, like I guess it's a good fit to use Xeon to do some fine tuning work for the large models as well. And most of these features are capable as sort of applicable for both inference and training.
Beautiful. Fantastic. Okay, see what else we have.
Okay. Um, oh yeah, this is just some sort of data point shows like comparing like the generation to generation comparison, right? Like with the torch.compile, right? Out of box, like if people compare like between the m7i instance versus the c6i instance, like between the latest generation and the last generation, what kind of accelerations that people can experience. And we use like the three benchmarks with here that got used a lot in PyTorch community to evaluate the torch.compile performance, which is Torchbench and Hugging Face and Teams, and I think it adds up to like more than 100 or around 200 models, right? And then as we can see, like it's up to 2.6 x accelerations between latest generation and the last generation.
So if you're using PyTorch 2.0 on, say, the last generation, which is the sixth generation at AWS,
Yeah,
just going migrating that workload to m7i instance will give
yeah,
you up to 2 times performance boost, which is pretty amazing.
yeah, yeah. That's a point.
Wonderful. Okay.
Yeah. Um, oh yeah, I do want to touch a little bit about the large language model optimizations here, right? Because that's almost like when I went to like whatever customers or people, like this is something that people for sure will be talking about, right? And then like we did do a lot of optimizations for large language models. Some of them have been upstreamed, some of them are still being staged in the extension, and we are working with upstream to figure out the way to get it available in stock PyTorch, right? So here are a lot of details here. I'm not able to read any all of this, right? But in general, like we do a bunch of optimizations for like for the for example KV cache or like the fusions and we support like all kinds of different lower precision like for the large language models, like people can even do int4, right? And we also support like the scale up scale out inference so that people can leverage like multiple sockets of a CPU server, or like course different CPU nodes in order to kind of like use multiple nodes or sockets or instances to do the inference to reach a good latency, right? Yeah, and we roll out an API in IPEX to incorporate all of these optimizations, so that people really, for users, they don't need to worry about like all of these optimization details, but they just use IPEX optimized transformers API in order to kind of like get all of these optimizations out of box.
So again, these are the, as you says, Intel extension for PyTorch.
Yes,
All done in open source. Just get
right.
it up and running on M7i instance c7i. This simple API, IPEX.optimize transformers, will figure out the right defaults for you, and it'll do the performance boost without going through the grunt work by yourself.
Yeah, that's right.
Wonderful. Okay.
Yep. Let's see what okay. So then I guess I can show some quick demos here.
Yeah.
Uh, let's see here. All right. Okay, so this is kind of like running like two generative AI workloads. One is Llama 2 for text generation, and then Stable Diffusion to generate image, right? And this is based on PyTorch 2.1 plus Intel extension for PyTorch 2.1. Uh, like, uh, yeah, so which are
So
both very,
what is the
right?
left side and what is the right side? Walk us through that one.
Which one?
Left one is the straight up PyTorch, and the right one is PyTorch 2.1.
Oh, actually, both are like this is actually a live demo that is set up based on the AWS like this
Okay,
M instance, and then I have both PyTorch 2.1 and IPEX 2.1 installed on that instance.
got it.
Yeah, and then the workload is run by utilizing both. Um, Let me show it here. Okay, so for example, I just get, since I'm located in Shanghai, so I'm just using Shanghai as a prompt here.
Yeah,
And this is using like Llama 2, I guess 7 billion to generate the text. Um, so the intention here is this is not a very kind of like a mature chatbot or something, but just to demonstrate like with the M7 instance, like it's totally capable of doing all these generative AI workloads. And
yeah.
actually, I think I'm using a 32 core instance here. And then so with this generated text, I can use the stable diffusion to generate an image. Oh, okay. I guess this is the Nanjing Road.
That's the image of
Yeah,
Shanghai. Yeah.
yeah, exactly. Yeah, so that's what it is about, and
And so
I
what
guess
we're demonstrating is straight up PyTorch running on M7i
yeah,
and doing text generation, image generation, simple tasks that people would do with this, and using Llama 2,
using Llama 2 and stable diffusion.
Stable Diffusion. Yeah, I got it.
Yeah, yeah, yeah. And then like as I just mentioned, since I'm here, I guess I can show like some of the latest documentations that we put together in the IPEX 2.1 release. Like we show some sort of validated topologies of large language models here that people can use. And since like these topologies are well optimized and validated with the latest release of IPEX. And we also put together some demos here, like the recorded demos here, so that people can get a feel here, and also some sort of like this live demos for people. Like since we put together some examples there, so that people can easily like trigger those and get a feel there. Right. So this shows some sort of steps like what command that people can use in order to get to trigger those examples and get a quick experiment going.
So
Yeah, and
people can clone this repo, they can run these samples on M7i to get a
yeah,
feel for themselves. I mean, we are
yeah,
seeing good improvement in terms of up to two times, like at least up to two times improvement. But they should definitely try it out in their environment and their setting and see how it works over there.
yeah, sure. Yeah, and as I just mentioned, like here are some sort of code examples, like in order to get the optimizations, we provide this API, right? And this is all that users needs to do, especially for BF16, right? Like they just use this API and they get all these accelerations for large language models. Um, yeah, and I guess what else? Oh, okay. As I just mentioned, like things for PyTorch 2.0 and 2.1, like torch.compile is really a big new feature or flagship feature there. And then like people can use like the default, right? Like they don't, if they do not specify any backend as a parameter for torch.compile, right? They just use the default. And that one is the one that we optimized in stock PyTorch, like the Torch Inductor CPU backend. That is well optimized as well. But then like people can also, if they want to experience some of the latest and greatest optimizations in IPEX, like they can also use IPEX as a backend here. So that they will be able to see like whether they can get additional optimizations with IPEX. Yeah,
So
but
this is where we can use a straight up, upstream PyTorch.
yeah,
Don't specify any backend. That is already optimized. But if you
that's
specify
already
backend as IPEX, then it
yeah,
knows that hey, you explicitly want to target to the Intel extensions, and that of course we have optimized.
yes, exactly.
Very cool. Very cool. What would you recommend? What do people do? Like, I mean, we talked about that. Well, any other slides or demos you want to show, or should we just get back to the discussion?
Yeah, I'm done. I think
Yeah.
that's all
Yeah.
that I'd like to show. Yeah.
So I want to bring you back here. So what I'm hearing from you is customers should look at M7i, C7i. These are the seventh gen instances on AWS. They download the upstream PyTorch 2.x. They will by default get all the optimizations. If they want to get more juice out of their existing M7i and C7i instances, they can also target to the IPEX backend.
Yeah.
That'll further optimize it. These are optimizations that are upstream, but not necessarily PyTorch upstream because these are Intel upstream essentially.
Yeah. You summarized it very well. That's exactly what it is. Yeah.
Fantastic. Well, so what is the call to action in that case? Just keep using PyTorch 2.0.
Yeah, I think it's kind of like we always recommend people to use the latest release of PyTorch, right? Because like PyTorch is kind of like evolving very fast, right? And people are continuously like, we are adding new optimizations and features, like the maintainers, the other maintainers, and all the community is working very actively in adding new features. So we always encourage people to try the latest PyTorch release, which is PyTorch 2.1 in this case, right? And we also welcome you to download the IPEX and just kind of like experience it and get additional benefit by using it. And if you see any issues, like we are at GitHub, we are at both the PyTorch GitHub and IPEX GitHub. So it's easily to reach out there. We are actually monitoring all these tickets very closely, and we will for sure provide you the response and recommendations.
Well, that's the beauty of operating in the upstream community.
Yeah.
Fan, anything else that I should have asked you that I didn't ask today?
No, I think that's all.
Wonderful. Thank you. Thank you for sharing this wonderful news. Again, the recommendation is keep using PyTorch 2.0, 2.x on the latest instances, and that should give you the maximum benefit out of it. Thank you, everybody. Thank you,
Yeah.
Fan.
Thank you.
Bye.
Bye.